Hi everyone, in today's lesson we're going to talk about a topic called differential equations. So today our goal is going to be, given a differential equation, dy dx, right? Differential means derivative. So given a derivative equation, can we write the general form of the original function, y equals? Now this is something you've seen before, but I kind of need to put it into a title called, differential equations. So let's just go through an example together. So we'll call this one example number 1. And let's just say I give you dy dx equals 4x plus 3. And the question basically asks you to write the general form of the equation in y equals. Basically, given the derivative, can you give me the original? And like I said, we've done this before, so it's just taking the antiderivative. So we're going to take the antiderivative of both sides, and then on the right side, we need to add a dx. So when I take the antiderivative of the derivative, you should be saying, well, you just get back the original. So we have y equals, and then we integrate the right side like we know how to. So 4x, add a power, and divide by that power. So it's just going to be 4x squared divided by 2 plus 3x, and then plus c. And then if we simplify it, we get y equals 2x squared plus 3x plus c. So basically, what you just found was an equation that represents this as the derivative. Now, there's an infinite number of c values that will give this as the derivative, right? Because if I take, let's just give a different example on the right over here. What if I said y equals 2x squared plus 3x plus 10, and I said find the derivative, right? You would get what? 4x plus 3, and then the derivative of a constant is always going to be 0. So this 4x plus 3, right, this derivative would exist for any value. So say I put 12 there or 13 there. Any number I put there, the derivative is still going to be 0. So this equation right here represents all the possibilities that could have this as a derivative. And tomorrow's video, I'm going to take it a step further, and I'm going to show you actually how to find that c value. So for now, we're just going to go backwards. Okay, let's try another example. So example number 2 is going to be y dy dx equals sine x. And I want to find the original function that this came from. So what we're going to do is we're going to integrate both sides. And again, when I integrate the right side, I need a dx. So when I integrate dy dx, or take the antiderivative, I'm just going to get y. And when I take the antiderivative of sine of x, you should be thinking this, sine, cos, negative cos. So I'm starting at sine and I'm going this way. So I go back around, and the antiderivative is negative cosine of x plus c. So again, that's going to be my equation that would have this as a derivative. Okay, let's try another one. So problem number 3, dy dx equals 1 over x to the third. So again, I want to find the original equation if this is the derivative. So I need to integrate and add a dx. So before I can even integrate, I think it would be helpful if we didn't leave this as a fraction. So I'm going to write this as dy dx equals x to the negative 3, right? We could bring the exponent to the upstairs and make it negative. And then I'm going to integrate. Right? So what do we have here? The left side is just y. The right side, remember, we're adding 1 to the power and then dividing by that number. So we have x to the negative 2 divided by negative 2 plus c. So my final answer is y equals negative 1/2 x to the negative 2 plus c, or any equivalent form. So you could totally take this exponent and bring it downstairs, make it positive, and that's another way to write that answer. All right, let's try another one. So what if I give you example number 4 and I say, okay, my derivative is dy dx, which is equal to 2 over x. Find my original function. So again, first thing, we're going to integrate both sides, add a dx when we integrate on the right. So we have y equals, well, if I integrate 2 over x, some people may think that this is similar to the first problem, or excuse me, the problem we just did, where you would take the exponent and bring it upstairs. But if you do that, you're going to run into a problem. If you add 1 to this exponent, it's going to give you 0. So you'd have 2x to the 0 over 0, which is not possible. So you need to think ln. So we can break this up a little bit more into 2 times 1 over x dx. And we know the antiderivative of 1 over x is just ln. So it's y equals 2 ln of the absolute value of x plus c. That would be my final answer. Okay, I just have 2 more problems up my sleeve for today. So for number 5, let's call this one dy dx equals 1 over x plus 1. And we want to find the original function. So to do that, we have to integrate both sides and add a dx. So what you should recognize here is that I can't bring this exponent upstairs, and it's attached by this 1 here. So you kind of have to think u substitution. So remember when I had a problem like this, I set the denominator equal to u. So my denominator is x plus 1. I take du, so the derivative of 1x is just 1. Derivative of the 1 here is 0, so we don't need to write that. So it's 1 dx. So if I solved for dx, dividing by 1, dx is simply du. So when we integrate the left side, we get y. And when we integrate the right side, it's just 1 over u. And dx is just du, so 1 over u du. So this is another ln problem, right? It's y equals ln of the absolute value of u, and then plus c. But you need to remember to substitute u back in. So since we let u equal x plus 1, the answer is y equals ln absolute value of x plus 1, and then plus c. All right, last one for today. So we'll call this one number 6, and we have dy dx is equal to negative 3 over x plus 1, or excuse me, x plus 3 squared. So again, directions are the same. Given the derivative equation, find me the original. So again, we have to integrate both sides. This needs a dx. When I integrate dy dx, I just get y. But when I integrate the right side, I have to use u substitution. So this stuff that's inside the parentheses is what we're going to let u equal. So we have u is equal to x plus 3. Du, the derivative of x is just 1. And the derivative of 3 is nothing. It's 0. So the derivative is 1 dx. So really, dx is just equal to du. So if we plug it in, we have negative 3 over u squared. And dx is just du. And this is what I want to integrate. So before I can integrate this, I probably should take this exponent and bring it upstairs. So I'll have the integral of negative 3 u to the negative 2 du, which is equal to y. And we can continue on the same. So add 1 to the power and divide by that power. So when I add 1, I get negative 1. Divide by that number, and then plus c. So to simplify a little bit, I have that, we can put y equals 3 u to the negative 1 plus c. And then just substitute the u back in. So y equals 3 x plus 3 to the negative 1 plus c. And I can show you another way to write this answer. So we could also write it as 3 over x plus 3 to the first. You don't have to write that. You could just leave it like this. And this would be your final answer. All right, that's it for today. Tomorrow we will find C. So try the problem set and see how you do.